friends, welcome back to yet another lecture in engineering mechanics. Today we are going to see the fundamental basic principles of engineering mechanics. Let us see the 6 fundamental basic principles of engineering mechanics. The first one is the parallelogram law for vector addition. And the second one is the principle of transmissibility. The third one is Newton's 3 fundamental laws, or first law of motion, second law of motion and third law of motion, and finally Newton's law of gravitation. So in today's lecture we will be focusing on these 4 Newton's laws. When we have a football or any object kept at some position, it is going to remain in that state of rest or in the state of uniform motion. When I say uniform motion, that means the velocity is a constant. So when an object is placed at rest, it is going to behave in the same way unless and until acted upon by an external force, and in this case the kicking of football. So Newton's first law tries to define what a force is and how an object gets displaced from its state of equilibrium. Coming to the second law. Now you can see this video, a rocket is set in motion, or rather it is accelerating. That is exactly what the second law is trying to say. When a body is not in equilibrium, that means there is a unresting force acting on the body. When that is happening, the rate of change of momentum is proportional to the force acting on it. The rate of change of momentum is otherwise known as acceleration. So the force which causes the unrest is directly proportional to the acceleration of the body, and the proportionality constant is here nothing else other than your mass. So the first law was trying to define the equilibrium. The second law is trying to define if it is not in equilibrium, that force, the total force, is going to have a proportionality to the acceleration. Now coming to the third law. So when I say there is a force which is causing an unrest, then that unresting force must be acting on some body, and that body will be applying an equal and opposite force. A Newton's cradle, the ball comes and hits from one side, moving the other side ball, that means it is transmitting the force through those row of balls, and it goes across to the last ball, which creates a momentum. In first law we were trying to define equilibrium. In second law we are trying to define the force which defies or which denies an equilibrium as proportional to rate of change of momentum. Then we are going to define, if at all that force is acting on a body, the body will definitely apply an equal and opposite force. Like in this case, when the ball is hitting on one side, an equal and opposite force acts back onto the ball, and that creates a disturbance to the other ball as well. Newton's law of gravitation. This principle was defined by Newton with a simple formula, that is, the gravitational force or the force of attraction between any two body is directly proportional to the product of the two mass and inversely proportional to the square of the distance between the two mass. When we say distance between the two mass, it is the distance between the center of mass 1 to the center of the mass 2. So these are the simple basic laws that Newton has defined and which forms the basis for engineering mechanics. I have explain to you the basic fundamental principle, that is the Newton's 4 laws. Remaining principle of transmissibility and parallelogram law of wet addition will be covered in the coming lecture. Thank you.